In this video, we're going to prove the De Morgan's law. So I've been given a question here to prove the De Morgan's law. So the first thing that you need to understand is a De Morgan's law, proving it is more like an identity in trigonometry. If you did those in lower level grades, you can relate with what I'm trying to say. So De Morgan's law here, we have from our left hand side is equal to the right hand side. So the first thing that we're going to do, we're going to take the left hand side to make it look like the right hand side. After we do that, we do the same thing. The right hand side, make it look like the left hand side. If we see, after we do this, we say the left hand side is coming to conclusion that is equal to the right hand side, and the right hand side is coming to conclusion that is equal to the left hand side, then we're proving the De Morgan's law. So there are different kinds of laws that we follow, and I'll be explaining those laws as we will be solving the question. So the first thing that we need to do when solving this question is understand what is involved in everything that we're going to be doing. So the first step is saying let x be the member of this. Sorry, I forgot one thing. I'm supposed to say left hand side going to the right hand side. Then I say let x be the member of the left hand side. Sorry. Okay. Then from there are basically three steps involved. The first step is expansion. So we're going to expand by saying x is a member of a component. Now remember, or you should know this, the n inside here will be replaced, n is equal to and. So when you remove the n inside the brackets, it become and. So the n become and, then x is a member. Since we're expanding, so we need to write for both a and b, a member of b complement. After expansion, so I said the first thing is expansion. The second is going to be factorization or word changing. It depends on the question. So let's see. So after doing the expansion, we're having this. Now, we can also, without changing the meaning, we can also say this same thing in other words. So we can say x is not a member of A. Or once I change from a member to not a member of, I need to change and to or. Even vice versa. If I had something like not a member of A or not a member of X, not a member of B. When I have this, I need to change. If I change this not a member of to member of, I need to introduce and. So we have this. We have X is a member of A complement, and X is the member of B complement. If X is a member of A complement, it cannot be a member of A without a complement. Understand that. If you are a member of CBU, you cannot be a member of Molongoshi or Unza. Let's just think in that way. I know you can be a distance learner there and there and that, or yeah, all those things, but let's just think like you can't have. If you're outside, okay, let's say this. If you're outside CBU, you can't be inside CBU. If you are outside UNZA, you can't be inside UNZA. So if we say, remember, complement means outside. So if we say X is a member of outside A, meaning X cannot be the member of A, which means X is not inside A or a member of A. The complement simply mean outside. So when we say X is not a member of A complement, we mean X is not a member of A, is not in A, but it is the member of outside A. This is what it means here. Then here it means X is not a member of A inside, but here it means X is a member of A outside. Complement. X is a member of A outside. So X is a member and everything outside A, and X is a member of everything outside B. But here we mean X is not a member of anything inside A, or X is not a member of B or anything. Sorry, I'm not supposed to put the complement here since we have changed the meaning. I hope you get it clear. Let's say it again. When after expansion, I have this, I've obtained this, which saying X is a member of A complement. Then remember, I'm saying complement simply means outside. So if X is a member of some outside A, then X cannot be a member of inside A. This is what the statement here means here. Then after having this, our next step is going to be factorization. So the second one was word changing. So what is changing? And to or. Then the third one is going to be factorization. Therefore, we factor now what is common here. We're going to factor this out and that. So we're going to have X is not a member of A. Then our or is going to change to union. So or represents union, cross bracket. So we say X is not a member of A union B. So if X is not a member of A union B, meaning it can be a member of A union B outside. So it can be a member of A union B outside them. So meaning X is a member of A union B complement. I hope that's clear. So after writing this, then we write this statement. Very important. So from where we are coming, from the left-hand side, we say, therefore, A complement intersection B complement. This represents intersection. Then you write your answer here. Okay. Then after doing this, we also do for the right hand side going to the left hand side. So we do the same thing. We say right hand side going to the left hand side. Then we say we take this, which is the which is our right hand side. So A union B intersection. So we're supposed to say let X be a member of this. So if X is a member of this, then X is not a member of A union B without a complement. Then we do the expansion. So X is not a member of A. Remember we said when you have union is equal to OR. So we're going to have OR. X is not a member of B. But if X is not a member of A or X is not a member of B, then it means X is a member of A complement. So after changing now this statement, you need to change also the OR to and X is the member of B complement. Then from there, we do the factorization. X is a member of A. Inside the bracket and changes to intersection B complement. Therefore, we write what we started with, which is there. We say B complement intersection. Sorry, subset, not intersection. Sorry. This means a subset of like that. Now, the last statement you need to say if what we answered here, if n intersection Bn subset, and you also write here, forgive me for my pen, it's the way I'm writing, which is not sufficing me to write properly. Then ends proven. This, after doing this, it means you have proven the De Morgan's law. You have proven the De Morgan's law. So we can go through for the last time. We can go through for the last time to see where we are behind. So what I meant, okay. So we can go for the last time. We said you have this. This is the question given. So after being given this question, you need to prove the left-hand side going to the right-hand side, also the right-hand side going to the left-hand side. Then you have proven. From there, we started with the left-hand side going to the right-hand side. From here, we said let x be a member of what have been given here. Then from there, we do the expansion. Since we can expand this, the complement is not outside like this one here. So we do the expansion, the first part expansion. We have this. After having this, then n, which is the intersection, changes to and outside the bracket is what we said. From there, we say, since if x is a member of a complement, if x is a member of a inside, then x is not a member of a. I mean, if x is a member of a outside, then x is not a member of a inside. So we do, from there we have this, we do the factorization, we have this, and we also write the final answer to say x is a member of complement. Then we start with this, going to the final answer, we write a complement intersection B complement. It's a subset of A union B complement. You do the same thing, right hand side to the left hand side, then we have obtained this solution. Thank you.